So when we look at this, we need to understand first that we are trying to optimize the cost. So one thing that you can also do is to first label your axes. So cost would definitely be on the vertical axis. You have a rectangular base tank and rectangular sides. So let me go ahead and draw this rectangular. Oops. Side right here. The width is 4. We don't know the length, and we do not know the height. But we all know that's 4 times length times h. It's equal to 36 cubic meters. If the building of the tank costs $10 per square meters for the base and $5 per square meter for the sides, what is the cost? So we need to look at the cost, and the cost would be, well, we have 2 components, the base and the side, right? The base and the sides. So the base is what? 4 times L is the base, and that it's going to be $10 per square meter. So that's why we do 10 times 4L. And the sides is going to be 5 times the total area of the sides. And we have 2 sets of sides. We have 4 times H, 2 of them. Okay, this side and that side. And we also have L times H, 2 of them. There will be this side and that side, right? All right. So now, again, we have the same dilemma, which is when we try to consolidate everything right here, we will quickly realize that we have 2 variables. We have L and we have H, and we cannot have both. So we have to make a decision. Do you want to have L or do you want to have H? In this case, it doesn't really matter as long as we solve for one and then we quickly get the other one. So then we say, let's go ahead and solve for H. So you have 9 over L as H. So we replace all the H's with 9 over L. So 40L plus 360 over L plus 90. Okay. So for the graph that we might draw, even though we are not going to draw it, that would be a cost versus length graph. Okay. So that's usually the first challenge. Do you have an equation? Or to be more specific, this would be a cost of a function of cost in terms of L. So the cost will change in terms of L. And we will go ahead and derive it so that we have C prime of L. We have 40. We have minus 360 over L squared. And the 90 will just disappear. Okay? And like as usual, we will try to find out where it is going to be. 0. Okay. So so we say 40, it's equal to 360 over L squared. So L squared is equal to 360 over 40, which is 9. So that means L is equal to 3. And if I know L is equal to 3, H is equal to 9 over L, H is equal to 9 over 3, which is also 3. So the dimension that we are going to seek is 4 times 3 times 3, or 4 meters by 3 meters by 3 meters. And that's how you get your lowest cost to build it. And also it still fulfills the total volume of 36 cubic meters. Okay, so make sure that you know what you're optimizing. Creating a pair of axes at the beginning would also be a good idea. I would say a lot of students who are clueless about what to do or what equation to write, it could be easily handled by setting up this pair of axes. And then you will realize that why we can only have one single variable, okay, in the function, because we can't do two variable system as of now. Okay, when you go to calculus 3, then yes, you would do two variable equations. But for now, we want to keep it as a single variable. Okay.